Okay, so we've got the degrees of freedom. We've talked about the sum of squares. We're ready to talk about the mean squares. Okay, so you're probably getting used to naming these things pretty easily now. This here is in the mean squares column, and it's in the groups row. So this is our mean square groups, okay, which I'm going to call MSG. Okay, and we're going to be able to calculate that from the sum of squares groups divided by the degrees of freedom groups, which we've already calculated. So sum of squares groups divided by degrees of freedom of the groups. So in this case, 16.96 divided by 2, that's where this 8.480 is coming from. Okay, this is a more standardized measure, okay, of variation between groups that takes into account the number of groups that there are. Okay, so this is kind of a way of standardizing it. So that's our mean squared groups. The other thing that we might want to calculate here, okay, this is, you might guess it, the mean square error. And we'll actually be talking about this one. This actually turns out to be pretty important or useful. The MSE, you might hear it talked about or reported in different papers. This is the sum of squares error divided by the degrees of freedom error. So we're just kind of dividing across. So in this case, we've got 37.33 divided by the 27. That's how we get the 1.383. Okay, so this is the variation between groups. This is our measure of variation within groups. And remember a while back, maybe let me just scroll back here. Remember a while back we talked about this, right? We said our F statistic was the variability between groups divided by the variability within groups. That's going to be our mean squared groups divided by our mean square error. So this next piece here, let me get all the way back to my other page. This piece here, this is our F statistic. Okay, so this is our F statistic or our test statistic. Okay, and it's always the mean squared groups, the variation between groups divided by the mean square error. So in this case, we do the 8.480 divided by the 1.383. Okay, and that's how we get 6.134. Okay, so you can kind of see that all the different values on this table are all interconnected to each other, right? If I give you the degrees of freedom and the sum of squares, you can work out the mean squared error and you can work out this F statistic. So that can be kind of useful. Oh, the last piece here, this piece here, it's already been given. That's our p-value. Okay, so that's the probability of being greater than that F statistic. So that's our p-value. And again, in R, it's going to work that out for you. So at least you sort of recognize what all those different pieces are. The other thing I'll just point out really quickly is R uses these significant codes, significance codes. So with this p-value, it already gives you the 2 stars, which means that this probability here is going to be rejected at this 0.01 level. So that kind of gives you some more information. Okay, so that's just a little bit about how it's calculated.